Okay, let's go to page 63, and this is lesson 5.4, and this is the polar coordinates. Okay, so again, when you have polar coordinates, like when you have a circle, okay, if you use a unit circle, so this would be, so this is r, and so this would be, and theta, so this would be r cosine theta. So x equal to r cosine theta, and the y, it would be equal to r sine theta. And if you use Pythagorean theorem, you can see that x squared plus y squared equal to r squared, right? X squared plus y squared equal to r squared. So r equal to square root of x squared plus y squared. So that's kind of relationship between the polar and rectangular. Okay, so let's go over some example. So example 5-11, it says convert rectangular point 3, -3 to polar coordinates. And so you got two parts. And the polar coordinate is 6, 30 degrees into rectangular. I think for most of the students, it would be easier to kind of just plot and have something to visualize. So you have 3, -3. So you got 3, -3. So the hypotenuse would be 3 squared root of 2. So convert that into this would be 3 squared root of 2, comma, so that's your radius. And the angle, now you can use positive or negative, doesn't matter. Depends if they give you the boundary or not. If not, then you can use -45 degrees, or if you go this way, it would be 3 squared root of 2, comma, you just add 360, so it would be 315 degrees. So you can, all these are fine, okay? Either one is fine. Now this one, when you're doing this, right, it's easy if you graph the angle first. So 30 degrees, so there's your 30 degrees, and it's 6 over here. Okay, so therefore this would be half of that would be 3, and it would be 3 squared root of 3. Use your spatial triangle. So in this case, your coordinate would be 3 squared root of 3. That's your x, and the y would be 3, and that's it. Okay. So again, if you draw out your triangle, it's not too bad. Okay, let's go to next example. Okay, example 5-12. Okay, so it's express x squared minus y squared equal to 9 in the polar coordinate. Okay, and again, just from what we had before, so you just go and substitute this into here. So x equal to r cosine theta, and there's a square over here, right? Minus y is r sine theta, and there's a square, and it's equal to 9. Okay, and then from here, you can multiply out. So you got r square cosine square theta minus r square sine square theta equal to 9. Then from here you can factor the r square. So you got cosine square theta minus sine square theta equal to 9. And this is the double angle for cosine. So you're going to get r squared cosine of 2 theta equal to 9. Okay, and that's it. Okay, let's go to next example. Okay, example 5-13. It says r equal to 5 over 3 minus cosine theta, and you want to convert this into rectangular. So first we're going to cross multiply. So you're going to get 3r minus r cosine theta equal to 5. Okay, and from here, then up to that, Okay, there are a couple we can do this. Okay, first we know that this is equal to, so you can do this. Okay, so r equal to square root of x squared plus y squared. R cosine is x. Okay, so you end up with that. Then so what you want to do is to get rid of the square root. I'm going to move this over. And I'm going to square both sides. Okay, to get rid of the square root. So I get 9 times x squared plus y squared equal to x squared plus 10x plus 25. Then after you can multiply out. So you got 9x squared plus 9y squared equal to x squared plus 10x plus 25. And then after that you can, I guess you can move this over. So minus x squared. So you can just basic algebra. Okay, so you're going to get 8x squared plus 9y squared minus 10x equal to 25, and that's it. If you can move 25 over here, that's fine too, either way. Okay. Now the rest of the section talk about various type of graph, and so you have different classifications. Okay, so it's just also different graph. So we're not going to cover this in details. Okay, so in a regular trigonometry class, it will cover more this into more details. Okay.